before, just a different command to start the Docker. So let's run this. Now we should see that there's container being created, and now you can see that the Docker is already running. So if it is running, it should send some messages. So let's see in the other terminal if it is receiving information. And as you can see, we are receiving hello world 15, 16, 17, 18, and so on, one every second. If we also would like, we can check the raw Docker, and you can see that this is outputting hello world. This is publishing hello world 31, 32, and 33. Okay, so this is all about the this part of the workshop. Why we are doing this? So basically, we want to give you the idea of what is needed to run the ROS applications inside of the Kubernetes environment, and also what also we want to say that all these parts that we are doing right now, in the end, will be automated inside of the 5G-ERA middleware that we'll develop later on this year. All of this should be automated, and with a single configuration, we should be able to deploy all those applications all together. Okay, so now let's move to the next part of the workshop, which is the showcase of the OSM system. What is the OSM? OSM is its full name is Open Source Manual, and this software allows us to automate the process of deployment of the network services, Kubernetes network functions, and take the load of us having to configure the Kubernetes environment and Kubernetes environment to take the load of us of manually deploying those services, and not only Kubernetes functions, but also using this OSM, we can deploy instances on public and private clouds like AWS or the Openstack just running locally on some of our own servers. This part of the tutorial, as I have mentioned before, finishes right after the process of installation of the OSM that you have been given in one of the emails with the technical requirements for the workshop. So the next part, the first part, we have to do the final configuration of the Openstack. To do so, we'll have to log in to the cloud virtual machine that we have created, and also to the one that was described in this graph. As you can see, this is the cloud virtual machine with the following IP address, which should be the same for you if you have followed this tutorial. And this cloud machine is running Openstack. So to do so, we will need to retrieve the password for the Openstack. We'll need the following command: sudo snap get microstack config.credentials.keystone password. By default, for the Openstack and the microstack, which is the minimal version of the Openstack that we are using currently, the password is not publicly available, and we have to access the Keystone service of the Openstack, which is responsible for the storing all the password and credentials and secure data inside of the Openstack. To do so, we'll just press enter, type the password for the admin, and as you can see, we've got this nice and beautiful password. To do so, we'll go to the Openstack Dashboard that you can access using HTTPS connection. For now, it's not secured due to the certificates in the current version of the Openstack, but we will connect to this via the 128.168.656.4. After we will type this address, we should see the warning screen on your browser. Then we have to press I understand the risk and take me further, and you should see this panel. We are using the username admin and the password, which the one that we have copied from the terminal. We will sign in. It should take us a second. And right now, you can see the overview of the OpenStack resources that it has available. So Zao, this is one of the places that you can see what kind of the resources are used currently by the OpenStack. But to do what we have to do, we have to change the network topo. We have to provide a small change to the network topology that is currently used. As you can see, I'll show you right now. When we have added the Kubernetes cluster with to the OSM during the configuration part, we have specified the Kubernetes network name to the management net. The thing is, by default, OSM does not have this this network name defined. So we have to rename the existing network or create a new one. We'll now change the existing network. To do so, we will navigate to the network in here, and then maybe I'll make it a bit bigger for you. We'll go to the network topology. Give it a moment so it will load. Now you can see the graph of all the network connections that we have. But we'll have to go to the topology tab. And then, as you can see, this is this test network. We'll click on this, and later on, we'll edit the network, and we'll just change the name to mgmt-net. And we will save the changes. Network management method was successfully updated. So now we should see that in topology, and now the management net is up and configured. And this is all what we have to do on the OpenStack side. OpenStack is already configured, and we should be able to deploy some of the example services. So now let's move on to the OSM virtual machine that we will have in here. And as mentioned in the tutorial, we have already downloaded the example packages that we will use, and we have extracted it to the OSM packages master folder. So let's enter this folder. And now inside, you'll see that we have really a lot of example functions to be deployed. For now, we'll use, for the testing purposes, we'll use the OpenLDAP KNF and OpenLDAP NS. Let's start maybe with the KNF. So we'll go to cd OpenLDAP KNF. And now inside, you can see that we've got two files. First one is the checksums, and the other one is OpenLDAP virtual network function definition in the YAML format. So let's once again edit this file. As you can see, it has the following contents. During the when we will edit this file, we will have to focus on two things. The first one is to specify the Kubernetes cluster net to mgmt.net, as we have did a moment before inside of the OpenStack. Also, we'll have to accordingly change all the all the places that this phrase is placed in this file. So this is case cluster. We'll specify the names, And that's it from this. But also what we'll have to have in mind is the identifier of this virtual network function definition. For now, it is named OpenLDAP KNF. It will be needed for us later on when we will create our own network service. So after this file is edited in the following format, if you haven't catch up at this, the whole file is placed in the repository, so don't worry about that. We'll exit and we'll move to the network service. As you can see, in here we've got some additional files, but we'll still focus only on the OpenLDAP and network service definition.yaml. We'll edit it once again. Now, as you can see, the structure is slightly different. What we'll have to focus in here is, once again, to specify the name of the network, which is the management network, and the virtual link profile ID, MGMT. We set it for mgmd.net. For the virtual link description, also will specify it to the management net. And there's one more thing which we'll have to specify, which is the identifier of the virtual network function definition, which is the function definition that we have touched a moment before, and we set it for the same name as the ID of this VNF. We'll set it for the OpenLDAP KNF. Once again, this file is present for you in the repository. So after both of those files are edited accordingly, we will exit the folder with the OpenLDAP network service, and we'll start deploying those Kubernetes network functions and network services with the according commands. To deploy the Kubernetes network function first, we'll use the following command. I'll increase this a bit for you. The command is OSM network function package -create, and the name of the folder in which we have the configuration, which is currently OpenLDAP KNF. We'll press enter. As you can see, the validation was successful and the package has been uploaded. Later on, we'll take a look on the graphical user interface side, how it is deployed. Later on, we'll also create the network service package in the same way. We'll use just slightly different function name, which is a network service package -create, and same as before, the name of the folder. Validation was successful and the package has been created. So now we can move to the OSM GUI, and we will log in using the default account, which is admin. The password is the same. Over here, we've got a dashboard, and as you can see, we've got one network service packages and virtual network function package, and one VIM account, which has been registered by us during the setup phase for the OSM. Right now, let's go to the packages on the left-hand side and see the VNF packages. As you can see, we've got one entry in here, which is the OpenLDAP KNF that we have created a few moments before. And also in the network service packages, we've got OpenLDAP network service. So what we can do now is we can actually instantiate this network service. So let's do so. We can do this using the graphical user interface, but also there's a way to do this using the command line. I'll show the command, I believe, is placed also in the repository. Yes, it is placed. So if you're interested in using the command line also for this task, there is already a way shown to you how to do this. To deploy the new instance, we'll have to specify its name. Let's name it for now